Welcome. Hi, and welcome to Iceberg and StarRocks' platform for analytics. My name is Connor Clark. I'm a staff software engineer at Demandbase. I've been at the company for over 2 years now, and during that time, I was part of the implementation of Demandbase's migration to StarRocks. A quick about Demandbase. Demandbase is a business-to-business sales and marketing SaaS company that helps companies with their go-to-market strategy. To accomplish this, we combine and process data from customers and third-party sources into a platform that allows customers to understand and use their data. That platform is backed entirely by a data lake and data warehouse stored as Iceberg, with StarRocks as the analytics engine. So why did we choose Iceberg to back our platform? Iceberg is supported by a huge number of tools, including the majority of well-known database engines like StarRocks. It supports concurrent writes so that many systems can write at once. And because it's just files and block storage, we have to pick. It is very affordable when it comes to storage, and we have the pick of the litter when it comes to compute. With all of these attributes backing our platform, we leveraged Iceberg as our data lake and data warehouse, which are all Iceberg. As you can see, we have several things writing to Iceberg. We have change data capture replicating Postgres changes to Kafka, and those get reconciled and written to the data lake and data warehouse as Iceberg. We have other sources writing directly to Kafka to be written to Iceberg and then the data lake. And then we have sources writing directly to Iceberg. Most of this writing happens via Spark, including the enrichment, which involves actions like creating and updating new tables and columns based on lake tables and changes made to them. Enrichment is a nightly process that enriches lake data into the data warehouse. Once all of this enriched data is sitting in the data warehouse, that data is at rest. Querying it is not particularly performant for analytics uses, so that's where StarRocks comes in. So StarRocks, we all know it's very fast due to the query optimizer, and it can handle a normalized schema such that we can make use of joins and save money on storage. Shout out to my colleague Nick, who spoke on this a few hours ago. StarRocks supports stream loading and does it very well due to how it handles upserts. And the big one, it integrates with Iceberg. StarRocks can query Iceberg by creating an external catalog. StarRocks treats that catalog like it's just more data in the database, allowing us to query the data like it's loaded into StarRocks itself, which brings us to how we use StarRocks and Iceberg together. As I mentioned, we can query Iceberg via StarRocks, and StarRocks supports insert overwrite via a select statement. Overwrite allows us to specify a partition and overwrite it, so we can update partitions of data directly from the Iceberg whenever we want. So I include an example here. Basically, insert overwrite, specify the partition you want to overwrite. You then specify what columns you want to pull from Iceberg, and then the Iceberg table, and then the where clause to pull the column for the partition. As part of this, whenever we StarRocks has built-in task queue, which we can submit these insert overwrites to. And that task queue is configurable for parallelization, so you can limit the number of concurrent jobs running at once. On top of this, StarRocks can stream data. So as I mentioned, we're replicating changes of Postgres to Kafka and from Kafka to Iceberg. We are using the same messages to update the data in Iceberg as well. We chose routine loads, but there are many different ways to stream data to StarRocks, including Kafka Connect, which is the first option we tried, but our change data capture messages were slightly different than what StarRocks needed to ingest, and changing that required a system overhaul. To make routine loads work, it was a small Spark job that transformed the messages we get from Postgres into a format StarRocks can consume, which we do via Spark. That message is basically just JSON with these specified columns and the values that go along with those columns, and then an additional field that is an op field, short for operation OP, and that is either a 0 or a 1 for create and update messages or deletes, respectively. We also make the tables that we are streaming to primary key tables to support the idea of upserts. Then it's just a matter of creating the routine load DDL to support your table. Routine load DDLs are very configurable. When it comes to Kafka settings, you can decide to start from any partition offset combination that you want. And then when it comes to the routine load itself, you have several options on how that runs. It can be a conditional routine load where you specify a column with specific logic, allowing you to decide when a record comes in, if it matches the logic, it will overwrite the message or the record that's already in the table. For example, if you set if the column was a timestamp column and you wanted the highest timestamp, if a record came in and the timestamp was higher than that of what was already in the table matching the primary key, then it would be overwritten. If it wasn't, the message would just be ignored. There is also full table routine loads, which is what we're doing in some cases, where you must specify all of the columns in the routine load such that the table is fully filled by the routine load itself. And then we finally have partial routine load, which allows you to specify a subset of columns, including the primary key, and update those columns by streaming the messages from Kafka. Partial updates leverage a combination of streaming and batch to provide customers access to net new records in real time. So net new records themselves are kind of challenging. We have a use case in our system that customers will import a bunch of data, and because of how we're replicating the data to the data lake, it would not show up in the platform until the nightly enrichment happens. Thus, this is where net new records come in. We stream the create and update messages, or create and delete messages, not update, directly to StarRocks to the routine load with only a portion of the columns needed for that table specifically to be loaded properly, such that they can see their data in the UI immediately. And then we can update the data later when the enrichment happens and then give them all of the benefits that Demandbase provides to them. But they get the full story eventually. We skip updates because those will be filled in by the nightly enrichment, making use of insert into rather than insert overwrite, which acts as an upsert. But since we aren't doing insert overwrite, we lose deletes. That's the reason we also need to stream delete messages. This is a great example of StarRocks and Iceberg coming together to provide near real-time access to our data. As I just described, here is that workflow. We have create, update, and delete messages coming from a data source into Kafka. The net new transform removes the update messages and passes along the create and delete messages, including that op field that has 1 or 0 for respective create and delete messages. And then the data warehouse enrichment, when it completes, it makes a request to StarRocks to do that that upsert as we described. Should stream loading fail as a result of net new process, we can always reload data from Iceberg because we are also streaming that data directly to Iceberg, making an excellent disaster recovery solution. Because Iceberg is our source of truth, it's something were to happen to our StarRocks cluster, we have several options. The most straightforward of which would be stand up a new cluster and load it from Iceberg. We also have a seamless upgrade strategy to limit outage issues, which is creating separate clusters, loading in them, and migrating traffic. So there are other implications for this, including standing up an elastic cluster that could act as a backup solution for if we were to lose the cluster. It could just be pointed at the Iceberg and query it. It would have it would have higher latency, but we would still be able to service customer requests. The other option is, because our data is just an Iceberg, we can stand up that separate query and load it directly from. Super useful. And then for the blue-green deployment, it's just a way to guarantee resiliency. It's our current upgrade strategy when it comes to going from to major versions. So we stand up a second cluster, and because Iceberg is our source of truth, we can load that second cluster with the same data that is in the primary cluster. We can mirror the load traffic to it, allowing us to run that cluster for a couple days, let it bake, make sure that it's stable on that new version. And then we can start routine loads on that cluster and just point it at the same topic that the original cluster is pointed at. As long as it has a different consumer group, we replicate all the changes that are there. We then can easily migrate traffic via Route 53 changes, and then terminate the old cluster. If something's bad, we can back out that Route 53 change. But all in all, that is the strategy. Now, I referenced mirroring of the load traffic. So we have a bespoke and boutique load service that we created. And our strategy with this load service is to make use of all of the great functionality StarRocks has to offer, but limit who has access directly to the system. A lot of internal services are writing to Iceberg and would also need to write to StarRocks. Instead, we made a small service that submits and tracks the completion of tasks to StarRocks and handles retries. Submit Task keeps record of tasks in the information schema task runs table. Thus, basically, the internal teams can submit a request that specifies the table that they want to load to, the table they're writing from in Iceberg, and then the partition that they're writing. And we take care of the rest, doing the submit task on their behalf, tracking the completion. Internal teams can call this service from within their pipeline to load data and keep track of the job without needing to write a query or know directly how to interact with StarRocks. We have a service for routine loads similarly, which accomplishes the same thing for creating, statusing, starting and stopping the routine loads. This is used by the Spark jobs that do the transform, allowing us to keep track of the schema in the routine load specifically, such that if the table schema were to change, the Spark job would identify that there's an issue. It would stop the routine load, pull the new schema, validate that the upstream data has that new column. It'll then start pushing out data with that new column and create a new routine load with that new column, such that the full routine or the full table routine loads would continue running with no issues and kind of adapt automatically. And that's kind of the whole picture of how Demandbase uses Iceberg and StarRocks together. This is how we're currently using StarRocks and Iceberg. Iceberg is the source of truth that we can easily load it into StarRocks, and StarRocks is the lightning fast analytics engine that backs our front end reporting systems. We do have some upcoming work that will expand on this diagram. We are currently working on productionalization of a shared data StarRocks cluster to act as a dedicated query engine for our data lake and data warehouse, with auto scaling to support ad hoc and background tasks reading from Iceberg. The intention for this is that we have a lot of Iceberg data, and that data comes with a lot of metadata. Querying all of that data at once with no regard can bring down our main production analytics cluster, which we do not want. Various services like AI that needs access to large amounts of data to affect that. So standing up a separate instance that is just querying StarRocks or Iceberg directly is the main use case there. We also have teams requesting usage of conditional stream loading, which requires a small change to our load service, and overall is a relatively straightforward change to make routine loads be able to do the conditional updates. The load service itself has some places for improvement, specifically in retries of those load tasks that we submit. Currently, retries end up getting delayed because they end up behind the rest of the things that get submitted where they should be higher priority. And finally, we have Iceberg as a source to load StarRocks internal tables, but some Iceberg tables are rarely used and could be queried directly from Iceberg. The external table, we have several Iceberg tables that don't necessarily need to be in StarRocks itself in a classic shared nothing cluster. we're looking into updating our analytics queries to make use of both, such that we can join data from internal and external tables live without needing to store that data in the cluster itself, saving us some space. So bringing it all kind of together, StarRocks and Iceberg are kind of like bread and butter, peanut butter and jelly. They're a match made in heaven. They just work really well together, and StarRocks makes it really simple to use. You can query Iceberg directly from StarRocks. You can load data from StarRocks from that query, and you can have StarRocks manage that load query in its task queue to completion. For streaming, you can just configure a table to point at a Kafka topic, and it kind of does it magically, and it's incredible. It rips through data on a Kafka topic. It's impressive at how quickly it moves through. That same Kafka topic you are using can be used to update your Iceberg if it's configured properly. And you can do a partial stream that allows you to get data in near real time to your platform while also updating it on the back end after you do the enrichment. And then disaster recovery, your data is always an Iceberg. It's just there to use. If you lose the cluster, too bad, you can just load a new one. If you want to upgrade seamlessly, great, the data's there. You don't have to worry about moving data from one cluster to another. It just kind of works really, really well together. It's an elegant partnership that we've established between Iceberg and StarRocks, and we're excited for the upcoming innovations that will only improve our workflows. And that's pretty much all I've got. Thank you for the time. I think we have opportunities for questions. Can we join the Iceberg tables not via StarRocks and StarRock table backed by Iceberg? If not possible, have you? Yes, you can do joins between internal and external tables. So in a shared nothing table, or in a shared nothing StarRocks cluster, you can do joins like that. It's just that queries may not be performant depending on the data that you're pulling from Iceberg. What is the scale of Demandbase Iceberg data? It's a lot. I don't know the number off the top of my head. I think the metadata for our one of our tables threatens the FE every time we load data from it. I can get back to you on that number. I think it's petabytes or close to that. How do you manage StarRocks deployment, VMs or Kubernetes? So we have dedicated, it's a shared nothing cluster. We have 40 backend nodes and 5 front-end nodes for the amount of data that we have. It's VMs, so it's all EC2 instances on reserved instances. I'm not positive on the size off the top of my head, but that's that. Did you experience any issues when concurrently write to the same Iceberg table from multiple jobs? The optimistic write in Iceberg caused race condition issues in my tries. We have a lot of things writing to the same tables in Iceberg. Fortunately, it's split on partition. So we have an ETL process that enrichment process that runs overnight. It's operating on partitions at a time and writing to those tables all at the same time for individual Iceberg tables. And we have not really had any issues. Have you compared performance between StarRocks native tables where you can define distribution keys, sort keys, buckets, indexes against Iceberg tables, which don't support those features? So during the POC, before we did the migration and how we decided to do the migration, we did a comparison between the shared nothing and shared data clusters. Where basically we were just querying against Iceberg tables directly versus querying a duplicate key table with not a lot of fanciness. It was very clearly significantly better querying from in storage tables or StarRocks native tables, as you put it correctly. versus Iceberg. But as we saw for the, I think 4.0 speaker notes, that those Iceberg table queries are improving, at least as StarRocks is putting out there. Anybody have anything else? Or did I answer your questions?
All right, yeah, I guess that is it. Thank you so much, Connor, for giving your time today on this session.